So we are talking about the analytical process and measurements. This was actually a research project that we were working on. Chronic exposure to benzene at levels near 20 ppb. What's ppb? Parts per billion. As present in several common sodas will likely cause severe illness. So if you have this preservative benzoic acid and citric acid, they can kind of react a little bit. It's very minutely, but you get some benzene in there. What's chronic exposure? That's why I inserted this picture. All right, this lady got way too much what? Well, in particular UV. She had way too much UV. Chronic exposure, right? You don't want to have too much. So I think it's got to be a lady, because look, she's got a little strap thing. Okay. Metric prefixes. Definitely know mega through pico. Mega is 10 to the 6, pico is 10 to the negative 12. So know those prefixes. Because if it's a homework question or an exam question and they say nanometers, well, they need to know that's 10 to the negative 9 meters, right? They're just going to assume that you know that. So make sure you know that. Alrighty. We have a plot. The X, oh, that thing is still going around, but I can just call on Jeff. Jeff, where's the x-axis?
It's the one parallel.
Yeah, there's our x. Where's the, so that means the y is up here. How about the Sabina, the independent variable? Because they use all these different words to make a plot, so we got to know all of them. Independent variable. Which axis is that? It's the x-axis. It's the x-axis. That means the dependent variable must be that y-axis. How about the abscissa? Gloria, how about the abscissa? You have a 50-50 shot at getting it right. Yeah, which axis is the abscissa? Yeah, you got it. It's the x-axis. Okay. So just be familiar with that stuff. Dilution. Brandy, what's dilution? Exactly. And she used the exact words you're supposed to use. You add a solvent to a solution, so you're just making it more and more dilute, right? So if you have two liquids, Melissa, and one liquid A is a lot more than liquid B, and I dump the two together, I have a solution. Which one's the solvent? The one with a lot of, right? So it doesn't matter whether you're putting a solid in a liquid or you're mixing two solids, it doesn't matter. The one that you have the most of, the compound you have the most of is always a solvent. Okay. Where are we? What equation is used? Marlena, what equation is used in dilution calculations, and what does each variable represent? Well, what's the equation first? Do you remember this? For dilution. Way back in Gen Chem. Yeah. Okay, now it's up to you. Sounds like Gloriana likes the numbers. I kind of like the I's and F's because it makes more sense to me. Initial and final. Okay. But either one works. MIVI equals MFVF. That's our equation. What do these variables represent, though? Kelly, what do the M's represent? Molality. What else could the M's represent? She said molality. Could be molarity. Well, mass, though, isn't the C word. It isn't concentration, so not mass. We've had molality, molarity. They're in that table. It's coming up. Volume percent, weight percent, just not density. right? So any concentration unit would work. This has to be the same on both sides. How about the V's? Ida, how about the V's? Volume. Could be in what units? Liters, milliliters, cubic centimeters, deciliters, centiliters, ounces. They just need to be in the same on both sides. Okay. After calculating with this equation, how do you prepare a diluted solution? So MF is always my diluted solution. That's my final. That's my diluted solution. Sometimes they call MI the what solution? It starts with an S. Not stronger. S-T-O-C-K, Andy? Stock. Sometimes they call it your stock solution, right? But I don't know. But the point is, one MI is your initial. MF is where you want to end up. So how do you make that diluted solution? Well, you have to know what volume you want to make. So that's what VF is. So the problem really comes down to just figuring out how much of that MI you got to take. And you take that amount of MI, you dump it in this, you dump it in that size flask, and you fill it up to the mark, and you'll have MF. Okay? And where things really get confusing with this question is so many problems, they give you the milliliters of that stock solution. Do you ever need to know that? No, you just want to make sure you have enough of it. So whatever you calculate for VI, it's always going to be less than that milliliters of stock, otherwise you can't even make the solution. But so don't let that confuse you when they give you the volume of the stock solution. Okay. This happens. This is going to happen. How do you prepare? So we can go through and we can calculate our answer, right? Get VI and we think we're done. But we aren't, because in these dilution problems, there's always a second part. And it's, how do you prepare? How would you prepare it? Easiest and most concise answer. But you have to know what variable to put into each spot. So you probably wouldn't put in, like if you calculated VI to be, I don't know, 20 milliliters, say, right? And where would the 20 milliliters go? So you put numbers in here, not really the variables, right? There's MI, VI, MF, VF, 1, 2, 3, 4 variables. So they'll go in there somewhere. Brandy, where do they go? Take VI of MI and dilute to VF MF. Exactly. So when they ask you how would you prepare, just remember this little saying, right? This little trick. And just put in the numbers for VI, MI, VF, and MF, and you're good to go. All right? You could explain it even more deeply, but this is about as short of an answer as you can give. The equation, Desiree, is really saying what initial equals what final of solute. What is it really saying? Anybody help her out? It's really saying what? Naya, what is it saying? It's saying moles. It's saying moles initial or grams initial equals grams final of solute. Moles initial equals moles final of solute. Mass or amount, right? The mass of, or the amount of the, initially you have the solute, is the same as the final amount you have of the solute. Because all we're doing is adding solvent, right? We're diluting. We're not adding any solute at all. So I guess you could say mass. That'd be the most generic way to say it. Mathematically, you might like the word moles in there because very often they use molarity as the most often thing. So moles initial equals moles final, but okay. So I think this is the meat of what we're going to do today. Let me give you some, show you where we're headed here, though. I'm going to jump down to this, the first question on this practice sheet. How many grams of 45 weight percent aqueous HCl, formula mass or molecular weight 36.46, should be diluted to 500 milliliters to make 0.1 molar HCl? Oh, right? Where would you even start on something like this? In Gen Chem, usually we had one measurement, and then we converted it to whatever, we took that measurement, that's where we started, and then we just converted it to the units we wanted. Right? You don't even have a clue where to even start on something like this. But it's the exact same problem. We're going to start with something, and we're going to convert it to what we want. But how do you play the game? This is how you play the game. So we really got to figure out this table and just ingrain it in our head. So what I'm after here is some useful definitions for density. We like to say density is mass per unit volume, but that's not going to help us solve these problems. So I want to call it, we're going to use of. I guess we could write of. Grams of solute all over. What are the common units for density? That's why I picked grams. Grams per mil. Milliliter of. Milliliters of. It's solution. Right? Because you measure density of something, it's not just the solvent. It's the whole entire solution, everything mixed together. So that's really important. Grams of solute, milliliters of solution. Okay? Weight percent. Grams of all over, let's put it in there, 100 grams of what? Grams of what over 100 grams of what? What would you guess? Grams of, these are all concentrations. Grams of solute, all over 100 grams of solution. The final mixture you got. Grams of solute over 100 grams of solution. Volume percent. Probably just guess what, Gloriana? If that's what weight percent is, what would you guess volume percent is? Milliliters of solute. All over. A 100 of solution. I'm already getting lazy. SOLN is my solution. Molarity. You already told me your name and I already forgot it. How would you define molarity, young lady? Kimberly. How would you define molarity? Grams over moles is molar mass. I'll give you a hint. It's moles of something over liters of something. Moles of solute, solution. Molality. Molality. Jacqueline, Molality. How do you define molality? Moles, good. Moles of what? Solute. This is the tricky one. The guy that's on the bottom. This one's odd. Anybody know? It's solvent, but what of solvent? Kilograms. Isn't that weird? All right. I can't stress it enough. Definitely know this table. Because this is going to make these problems that look so complicated, they're not that bad at all. This is how we're going to write these things. Okay. So what I want to do first is I want to, these are, measurements that are in these really complicated, ugly problems. This, writing 2.8 molar HCl in this format doesn't help us at all solve these problems. I want to write it in the format in this table. So I would write it as, for example, 2.8 moles of what? HCl per liter of solution. Okay. Yes?
I was confused about the density one up there that we did a while ago. It's the density of what?
Anything. Let's jump down to that one, Ricky. Okay. Let's do that one. It's the one over here in the corner. Okay. We have 0.874 grams per milliliter of this benzene. Okay, that's the density of benzene. Leaving it like this doesn't help us solve the problems. We need to write it as what? Ricky, what would you write this as? What over what?
Besides kilogram per liter?
It has grams per milliliters in it. Follow the density idea. The density idea is grams of solute over milliliters of solution. I guess solute really doesn't make much sense, but it's.
Yeah, I was just confused because I guess.
What is the substance? What is the substance? Benzene. So we're going to write 0.874 grams of benzene. All over. What would you put in the bottom? A milliliter of solution. Now, the terminology is kind of odd in the sense that this is pure benzene. So you really don't have a solution, but you get the idea. That this will work. Most everything in nature is a solution. Salt water. You'll have so many grams of, let's say, salt water solution, whatever, all that stuff in there per milliliter of salt water solution. So it's just using the idea of solute and solution is just really generic just to help us to write this. How about the jump up to the 2 weight percent NaCl? Did that little thing make it all the way around so I can be fair picking on people? I just pick on Danielle anyway. Danielle, how would you write 2 weight percent NaCl in a format that's a little bit easier to use? All right. Weight percent is right here. Yeah, how many grams of NaCl? How many grams? It says 2. Divided by what? 100 what? Grams of solution. 2 grams of NaCl over 100 grams of solution. Okay. How about this next one? Little m stands for molality. So your hint. Jeff, what would you write here? 3.9 molal nitric acid.
3.9 moles of nitric acid over 1 kilogram of water.
Good. How do you know it was water, Melissa? Because it says aqueous. So do these last two, then I'll ask you. Okay, Sabina's been unscathed so far here. Sabina, how would you answer this weight percent one? Yeah. Over 100 grams of solution. How about Gloria, the last one we haven't done yet? Perfect. Okay. So if you look at, does this make sense? Okay. So if you look at the assignment sheet, this is some homework here. You have to knock this thing out. Okay. And your numerical answers are on the bottom. So what I did is I blew up the first one so we can work on it here. So how many grams, so you'll tear out that page, right, and you'll turn that in for next class period. How many grams of 45 weight percent aqueous HCl should be diluted to 500 mils to make 0.1 molar HCl? So let's go ahead and start listing this stuff out. We're going to start with one thing, do our whole box thing, right? Get units to cancel and get our answer. Remember doing that? That's exactly what we're going to do. But where do you start? Where do you end up? Let's just get get everything in this format. Everything that's written in that problem, and then we'll see where to start. It'll stare at us where to start, actually. So what are these? Here's one that we have to write. Here's one. Here's one. Here's one. Right? Okay. Yes. FM is, what does FM stand for? Formula mass. So it's just the molar mass. It's the molar mass. So I guess I should have probably underlined this too, right? So let's go ahead and get started. How many grams? So we want to know, what's the units of what we're looking for? Now remember, it needs to be something that's going to fit into this table. And if you say just grams, that's not going to work, because it needs to be grams of solute. What's another possibility? Grams of solution. Oh, well, that's about the only choice, right? Which one is it? It's grams of solution. All right? And it's actually which solution? The
500 mil one?
It's the what concentration? It's the this solution that we're looking for, what's its concentration? What's the like we're talking about some solution, we don't know the grams of it, but what solution are we talking about? Well, we want to end up making that, but this grams of solution we're going to calculate, that's not of the 0.1 molar HCl. It's that 45 weight percent stuff, right? That's the solution that we're trying to find. How many grams of 45 weight percent, blah, 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 blah. So this is the 45 weight percent stuff. So I just want to indicate that somewhere so I know that's the 45 weight percent stuff. Okay. So we have 45 weight percent HCl. So let's write it the way we're supposed to write it. We're supposed to write it as 45 grams of HCl all over what again? Kimberly? 100 grams of solution. Okay. Formula mass. How could we write that? 36.46 what? Grams of what? HCl all over what? 1 mole. But mole of what? HCl. And there's a big difference because if you just stop at 36.46 grams and 1 mole, you're going to be just as lost here as you were just reading the question. So you got to be really specific with this stuff. 45 grams of HCl, 100 grams of solution, 36.46 grams of HCl, 1 mole of HCl. It'll make it so much clearer how these units are going to cancel out on you. And we have 500 mils. Yep. You can go into my office. There should be a bunch. Just give them to them. Yeah, I think that's where they're at. We have 500 mils of solution. We have another one is 0.1 moles of HCl per liter of solution. Okay. Now the reason why I wrote all this stuff out is because then I can figure out where to start and where to end up. Now, the units of my answer were this grams of solution stuff, right? Do you see that anywhere in here? Do you see it? Naya, do you see it where? Yeah. Here's your answer. Right there, those grams of solution. That's your answer. This is it. This is what we want to find. So let's start there, except we should do what? We should flip it, because then our right answers are up there. We'll have 100 grams of solution all over 45 grams of HCl. It has, because there's got to be a lot of ways to solve this problem. But in every single way, doesn't this have to be one of the terms? That grams of solution has to be up on top, because that's what you're looking for. So now the game is just keep playing this game until all your units cancel and all you're left with is 100 grams of solution. You don't have to start with this guy. But I know that it has to be written this way in everybody's solution. No matter how complicated and ugly you make this, this has to be in everybody's solution, because those units are right and they're on top. So we might as well just start with that one. What could you use next? And here's what you have to work with. Yeah. We don't have any choice. It's the only place grams HCl shows up. So use that one next. 36.46 grams of HCl in 1 mole of HCl. Now, do you see how big of a deal it was to write down here when we did this? To write grams of HCl and to write moles of HCl? Because if you didn't, you're going to have no clue what to do next. So you have to write those. All right. Now it looks like our grams of HCl are gone. It's got to keep going. What would be next probably then? Yeah, 0.1 moles of HCl. Then you see what's going to be last? That's how we get rid of the solution. And then we have 500 mils of that solution. See, diluted 2 500 mils to make 0.1 molar. So this is the 0.1 molar solution. All right, so you're going to take 500 mils of it, which is how many liters? 1, 2, 3. All right, 0.5. All right, or if you're not, do you remember doing that kind of thing? 500 milliliters, 1,000 milliliters in a liter, 0.5 liters. All right, so this is really just 0.5 liters. Where do I put it, top or bottom? Bottom, otherwise it's not going to cancel. Ah! Thank you. I didn't write it right. Otherwise it won't cancel on me. So now I have to write it on top. So now everything should cancel. And I'll end up with the units that were left. The grams of that 45 weight percent solution. So an order doesn't matter. Just whatever's on top, multiply. Whatever's on the bottom, you divide by. The order doesn't matter at all. So I got about 4.05 or so. So if you want to make 500 milliliters of 0.1 molar HCl, starting with the 45 weight percent stuff, well, you pretty much have to mass out. Man, can you even read that? That orange color is really hard to read. 4.05 grams. You need to mass out 4.05 grams of that 45 weight percent stuff. Dilute it to 500 mils and you'd have it. Okay. Okay. Try the second one. And we'll work on it together after you give you some time to figure it out. So because FM means molecular weight or molar mass, and molar mass is always grams of the stuff over moles of the stuff, grams per mole. Remember when you did the periodic table, you add up all the stuff, you always typed grams per mole. But now grams per mole isn't good enough. You have to write grams of HCl over moles of HCl. So you have to actually write down what the compound is, otherwise it's going to get confusing. After class, yeah. Make sense? Yeah, just realize FM is the same. Sometimes they, instead of writing FM, they write MWT. Wow, how do you write MWT, right? Sometimes they just write that. So, yeah, they both mean molar mass. Yeah, they're always, molar mass is always grams over moles. Okay. Now, if you're like me, you probably started listing out all these conversion factors to fit the table. However, you don't need all that stuff for part A. Why? Because look at part A. Do you remember how many mils of concentrated nitric are needed to prepare 2.5 liters of 2.5 molar NaOH? This is the dilution problem. That MiVi equals MFVF. Because you know Mi, you know MF, you know VF. You just have to solve for VI. You see that for part A? Now, part B will be one of those long ones that we just did. You're going to have to do a lot of converting. But for part A is just a dilution problem. And I guess there's a couple hints to that. One is, if you look at the dilution equation problem, equation, if you ever see two big M's, expect it to be a dilution problem, because it's got to be, right? It really will be. Now, I bet you could work it out a longer way too, but it's simpler if you just use the dilution problem, the dilution equation for part A. So figure out what the final concentration is, right? And they want to know how many milliliters of concentrated nitric are needed, so you're going to solve for VI. The other ones you should be able to find. You see this, Ida? You see what Mi is going to be? Mi is going to be the initial concentration. What are they starting out with?
2.5.
Well, that's where they want to. That's where they want to end up. And they want to make 2.5 liters of it. So that MF would be 2.5. VF would be 2.5 liters. But the MI would be. Yeah. The 15.4. Exactly. That's the MI. That's what you're starting out. Or you could change that 2.5 liters to milliliters right away, so you don't have to convert at the end. But So hopefully you got about 406 milliliters for part A, right? And I've just done this a lot, but I know that when I'm going from liters to milliliters, right, if you're not comfortable with just moving the decimal place over 3 places to make it bigger, then just do this a few times, and after a while you get used to it. There's always, a liter is always 1,000 milliliters. Okay. So part B is the one that's kind of long. See if you can write out all those conversion factors. See a good place to start with all those conversion factors you wrote. Okay. Now, hang on, what units am I looking for? Yeah, now remember, you have to get out of the habit of saying grams or milliliters. Grams of what over milliliters of what? Grams of, go back to the density table. Go look at the table. What does it say? Grams of solute. Did I write that wrong? Density. Ah, my goodness. I did write it wrong. It's not grams of solute.
That's what I was asking you, but I didn't want to be a jerk about it. I was like, really confused.
Right?
Sorry.
So, because grams of solution over milliliters of solution. Because if you find the density of anything, don't you just take that whole thing, whatever it is, and you mass it? Then you take that whole thing, whatever it is, you find the volume, and you divide the two. Right? I got into the solute kick. So density is just grams of solution over milliliters of solution. Yeah. Okay. So what are we after? What units are we after? We're after grams. Yeah, grams per milliliter, right? But grams of what? Solution all over milliliters of solution. Right? Where I screwed up. Ah, goodness. Right? I want grams of solution over milliliters of solution. Okay. That's what we want, is this. So where, Brandy, would be a good place to start, or a possible place to start with this mess that we have? Where could we start? This one? Okay. Write it as is, or flip it? Flip it. Great, that's one starting point. There's another starting point you could have. Do you see what it could be?
Could you start with the
Start with what?
Can you start with the density?
No, we want to. No, it'll be confusing. Brandy found one starting point. Great, but you're gonna have to flip it. And that's fine. You can do that. There's one other starting point that will definitely work. The 15.4. Do we want to flip it?
No.
No. But you'll have to, convert those liters to milliliters, but you can do that and you just keep going. So, which way do you want to go? This one or that one? Where do you want to start? The 15.4 way? Okay, let's start that way. 15.4 moles of HNO3 per liter of solution. Okay, start that way. Keep going until you end up with grams of solution up on top. Oh, and you need mils of solution on the bottom. Right, don't forget about that one.
We still have to flip the middle one though, right?
Yeah, oh yeah, you will. No matter whose solution it is, you're going to have to do it. Oh, that's not right. I don't know, why am I writing everything upside down? And then it's got to be that last one. Yeah, it works out, doesn't it? It'll work out. The key really is writing all these out, right? Write out all of these terms like molar mass, concentrations, all of them in a way that's user-friendly. Then you look through them and look for the units of what you're interested in. And that tells you your starting point. And then you play the game of canceling units. So everything on top multiply, everything on bottom just divide by. So I got about like 1.38 or so. Okay. So if you're not so sure about this, give the handout a try. Come by and I'll be glad to help you out. All right? Tomorrow, I'm sure we won't be in lab the whole time, so that'd be a great time to help you out there on this kind of stuff and give you some more practice.